students, welcome to Diksha Vedantu Foundation channel. So as you know, your midterm exams are approaching, so we have come up today with a one shot of the most important chapter for your 10th midterm, that is acids, bases and salts. Okay, so here we'll be discussing all the concepts in detail, and then we are going to practice 20 important questions that can be asked in your midterm examination. Okay, so yes, now I want all of you to sit with a notebook and a pen and note down all the important reactions, important definitions and important questions. Okay, so yes, now let's get started here. So first one, we'll start from the very basics, that is what is an acid. So an acid is a hydrogen containing substance, okay, that is capable of donating a proton. So acid is something which can give you H+, okay. Next, acidic solution turns blue litmus paper into red, okay. So blue converts to red by acids. So you can see here we have taken a blue litmus. If you put it in the acidic solution, it will get converted to red. Okay, now examples of some acids are HCl and HNO3. Okay, now apart from strong acid in our stomach, human bodies are also are known to produce lactic acid while exercising. So there may be a small MCQ like what is the acid produced in the body. So lactic acid is also produced in a human body during exercises. Okay, okay, fine. Coming to next definition, we are going very fast in these basic things. What is a base? So base is a chemical substance which have a bitter taste, soapy feel to touch and turns red litmus blue. Okay, so base turns red to blue. Okay, next it dissolves in water to produce hydroxide ions in the solution. So as you know, acids gives H+, base will produce OH-. Okay, now here one more important thing that we talk about is alkalis. So what are alkalis? Alkalis are those bases, okay, which are soluble in water. Soluble in water. Okay, now examples of some bases, if you see NaOH. Okay, here OH- is produced, calcium hydroxide is there, okay, magnesium hydroxide, these all are the examples of bases. Now here you can see it changes the red color to blue. Okay, litmus color change happens in this way. Now lead litmus paper into blue, examples are NaOH. When you dissociate in water, it gives you Na+ and OH-. Okay, fine. Now coming to salts. So salts are produced when an acid and a base react. So salts are produced due to the reaction between acids and bases. Okay, so there are so many examples. For example, if you see the most common salt NaOH plus HCl, okay, it will give you NaCl plus water, right? Okay, next coming to the chemical properties. So here we are going to see the reactions of acids and reactions of bases. So in reactions of acids, we have reaction of acid with metal, with carbonates and bicarbonates and with metal oxides. And for bases, it is with metals and with non-metal oxides. Okay, so now if we see here, first one, that is reaction of acid with metals. So when acid reacts with metals, we get salt plus hydrogen gas. Okay, so very important, salt plus hydrogen gas. Now what happens? Example for this one, you can see zinc is a metal, sulfuric acid is a acid. Now this is the salt, zinc sulfate, and then hydrogen gas is produced. Okay, so now the properties of hydrogen gas is colorless. Okay, now most of the time a question is asked how to test this gas. Okay, so how to test this gas? If you take a burning matchstick, okay, then it makes a pop sound. Okay, that is how we can identify the hydrogen gas. Okay, next coming to next one. Okay, reaction of acids with metal carbonates and bicarbonates, or we call it hydrogen carbonates. So acid plus metal carbonate will give you salt plus H2O plus CO2. Now example is sodium carbonate. If you react with acid, it will give you salt plus H2O plus CO2. Now sodium bicarbonate, if you react with HCl, it will give you salt plus water plus CO2. Okay, fine. Next is reactions of metal oxides with acids. Okay, so when acid reacts with metal oxide, we get simply salt and water. Okay, salt and water. So example, copper, this is metal oxide. okay, and it is reacting with acid to give you salt and water, right? So now let us recap all the three reactions of acids. So for acids we have, first one is reaction of with metal. With metal it is giving you salt plus H2, okay, salt plus H2. With carbonates and bicarbonates it is giving you salt plus water plus carbon dioxide. Now with metal oxide it is giving you salt plus H2O, okay. So we can write it together once here. So see, acids, okay, plus metal will give you salt plus H2, okay. Next, with metal oxides it will give you salt plus H2O, and then you have carbonates and bicarbonates. This one will give you salt plus CO2 plus H2O, okay. So these three reactions we have studied under acids. Now coming to reactions of base, okay. So base, there is first reaction is base with metals. So if you remember, what is same thing with acid, with metal also we get salt and hydrogen, with base and metal also we get salt and hydrogen gas. So it is very easy to remember. Now example, but this is very important example, NaOH plus zinc, it give you Na2ZnO2, that is called as sodium zincate, okay. And then we have hydrogen gas. So next one is the reaction of base with non-metal oxides, okay. So you remember acids reacted with metal oxides and bases will react with non-metallic oxides to give you the same product, salt and water, okay. So for example, you have carbon hydroxide with carbon dioxide, so this will give you salt, calcium carbonate and water, okay. So bases will react with non-metallic oxides to give you salt and water. Acids will also react with metallic oxides to give you salt and water, okay. So with bases we have two reactions, okay. Bases, if I write, okay, they will react with metals to give salt plus water, and with non-metal oxides, with non-metal oxides to give you base with non-metal oxides will give you salt plus, sorry, this one is water. With metals it is salt and water, with oxides it is salt and, with metals will get salt and hydrogen gas, and with the non-metal oxides will get salt and water, okay. So next, coming to, okay, now then we have seen the difference between their reactions, their properties, right? Then do acids and bases have anything in common? So yes, there is something common between them also. They both are electrolytes, which means that they are good conductors of electricity, right? Acids and bases both produce ions in the water solution, okay. So now when you put acid in a water or base in a water, ions are produced due to which they can conduct electricity, okay. Now acids release H plus ions, whereas bases release OH minus ions, okay. Next, the process of mixing acid or base in water is an exothermic one, okay. So when you dissolve acid or base in water, heat is generated, okay, heat is liberated. In the previous section where we discussed the type of reaction, there we discussed exothermic and endothermic, right? So this is an exothermic reaction where heat is liberated, clear? Okay. Next, coming to strength of an acid or a base, okay. So the solution is considered to be acidic if the pH of the solution is less than 7, okay. If pH is less than, so there is a pH scale. What is this pH scale? Which tells us about the acidic or basic nature of the solution. So if the pH is less than 7 here, then it is acidic range, okay. And if it is more than 7, then we call it base, and at 7 it is called as neutral solution, okay. So, okay. So now the solution is neutral if the pH is around 7, and if the pH is greater than 7, the solution is called as basic, right? The abundance of hydrogen ions in an acidic solution then is greater than that of the hydroxide ion. So in an acidic solution, okay, what I say, so what I mean when the solution is acidic, there is more H plus. When I say the solution is basic, there is more OH minus, Okay, so in acidic solution what will happen? H plus concentration will be more than OH minus concentration. Okay, fine. Next, coming to indicators. So this is very important. Indicators are what? Those chemical substances which help to detect the nature of the chemicals. Means what they will help to detect? They will tell that whether the substance is acid or base. Okay, they, like suppose the substance is there. Okay, by using indicators we can tell whether that substance is acid or base. Now for example, you take red litmus. Okay, red litmus solution you take. Now suppose this solution is acidic in nature. Okay, you have taken HCl here. Now when you add red litmus, the red litmus will remain as it is. But if this solution is a base, NaOH, then in that case what will happen? The red litmus will turn to blue in the color. So by that we can know that this solution is basic or acidic in nature, right? Similarly, if you take blue litmus, it will turn red in the acidic medium and it remains blue in the basic medium. Now if you have turmeric, there will be no changes in the acidic medium, it turns red in the basic medium. Now phenolphthalein, it remains colorless in the acidic medium but turns pink in the basic medium. Now methyl orange, it remains red in the acidic solution and turns yellow in the basic solution. Okay, so these are the color changes that will help us to identify whether the given compound is acidic or basic. Okay, fine. Next, there are some other indicators also called as olfactory indicators. So olfactory indicators are those whose smell changes in the acidic and in the basic solution. Like for example, those substances whose odor changes in the acidic or basic medium are called as olfactory indicators. Now example, if you see vanilla, onion, clove, smell of the onion and vanilla diminishes in the base and remains as it is in the acid medium. So if you take onion and keep it in a basic medium, the smell of onion will decrease. Okay, and if it is in acidic medium, there will be no change. So by the change in the smell also, some compounds can act as an indicator. Okay, fine. Now coming to something called as universal indicators. So those substances which not only detect the nature of other chemicals but also determine their acidic or basic strength are called as universal indicator. Example is pH paper. So if you see in the pH paper, pH paper, if you have seen, we can not only say that whether it is acidic or basic, but we can also tell what exactly is the pH of the solution, whether it is 7, 6, 5, 4, 3. So those type of indicators which not only tell us about the nature of the chemical, whether it is acidic or basic, but also tells you about the strength of that material, strength of acid or base. That type of indicators are called as universal indicators. Okay, so in indicators we have seen, first we saw olfactory indicators, then that is universal indicators. Okay, fine. Next, coming to neutralization reaction. So neutralization reaction is the reaction between a acid and a base. Okay, now if there is a strong acid and a strong base, then it is a neutral salt. We'll get a neutral salt plus water. Like for example, NaOH plus HCl will give me NaCl plus H2O. Okay. Now if you take strong acid and a weak base, like for example HCl, okay, weak base is NH4OH. Now the salt here produced will be NH4Cl plus water. Okay, now see, the nature of this salt will be acidic in nature. Why? Because we have used a strong acid. Okay, if you use a strong base, the salt will be basic in nature. If both are strong acid and strong base, then the salt will be neutral in nature. Okay, so now if I see this one, weak acid is your CH3COOH plus strong base is NaOH. Right, so this one will give me CH3COONA plus H2O. Okay, CH3COONA plus H2O will be produced. Right, so now this one will be a basic salt. Why? Because the base here is a strong base. Right, this is a strong base, this is a weak acid. Right, so strong base is there. Strong base reacting with a weak acid will give you a basic salt. A strong acid reacting with a weak base will give you acidic salt. Okay, fine. Next, coming to some important salts that we use in our daily life. So first one is your common salt. We'll be studying all of this in detail. So first is common salt, then we have bleaching powder, baking powder, washing powder and plaster of Paris. Okay, what are these salts? Common salt, bleaching powder, baking soda, washing soda and plaster of Paris. Okay, so we'll start one by one. First is your common salt. So how common salt we get? See, when electricity is passed through an aqueous solution of sodium chloride NaCl, it decomposes to form sodium hydroxide. Okay, the process is called as chloralkali process. Okay, so now if you see, when NaCl is there and you treat it with water, we get NaOH plus Cl2 plus H2. Okay, and this is the chloralkali process. Now what happens? Now this is your NaOH whose uses we will see, H2 uses we will see and Cl2 uses also we will see. Okay, okay. Now if you see NaOH, it is used in the preparation of soaps and detergents, used in paper making and used in artificial fibers also. H2, which is a byproduct, it is used as a fuel, it is used in margarine and it is also used as an ammonia for fertilizers. Now coming to chlorine. Chlorine is used in water treatment, in swimming pools and as disinfectants. Okay, so that is the first salt that we are studying, that is NaOH. Next, coming to bleaching powder. So bleaching powder, I think, is now the use of bleaching powder nowadays has decreased because of its toxic nature, but yes, the formula of bleaching powder is CaOCl2. Okay, yes. Now the chemical nature of bleaching powder is calcium oxychloride, that is CaOCl2. Now how it is produced? If you take calcium hydroxide and treat it with chlorine, we get calcium oxychloride CaOCl2 plus H2. Okay, now this CaOCl2 is your bleaching powder. Bleaching powder is CaOCl2. Okay, next coming to, it is used for bleaching cotton, for just removing the color, bleaching cotton, as an oxidizing agent in chemical industries and used as a disinfectant of water. Okay, so these are the uses of bleaching powder. You need to remember at least 3 uses and the chemical formula. Okay, fine. Next, the third one if we go, that is your baking soda. I think all of you would have used it, baking soda. It is widely used in food and making bakeries and all. So now the chemical nature of baking soda is sodium bicarbonate, that is NaHCO3. Okay, and if you remember, bleaching powder is calcium oxychloride. Okay, this is sodium bicarbonate. It is produced on a large scale by treating cold and concentrated solution of sodium chloride with ammonia and carbon monoxide. So what is saying? NaCl solution with carbon dioxide and ammonia. If you treat, we get ammonium chloride and bleaching powder. And baking soda. So we'll get this one, NaHCO3, which is your baking soda. Right, NaHCO3. Now what are these properties of this baking soda? So if baking soda is there, if you heat it, it will get converted to Na2CO3, H2O and CO2. Okay, so this is the reaction of baking soda. It will get converted to sodium carbonate, CO2 and H2O. Now what are the uses of baking soda? It is used as an antacid to treat acidity in stomach. Okay, next it is used to make baking powder, which is used in the preparation of cakes and breads, etc. Okay, so baking powder, what exactly is happening? See, when you use baking soda, it produces carbon dioxide, right, and this carbon dioxide is responsible for making the fluffiness, okay, the softness that you feel, okay, that is formed due to the trapped carbon dioxide in the cake and all. So we need this NaHCO3 to produce this carbon dioxide. Okay, so when baking soda is mixed with baking powder, we use this to make cakes and breads, etc. Okay, fine. Next one is your washing soda. So that is sodium carbonate dot 10H2O. And the chemical name of okay, so this is washing soda. The chemical name of washing soda is Na2CO3 dot 10H2O. Okay, now as you can see, it is used in the used in glass, soap and paper industries. It is used in the manufacture of sodium compounds such as borax, and it is used to remove hardness of water. Okay, so you can also write it is used as a cleaning agent, right? We widely used washing soda for cleaning agent. Okay, fine. Next, coming to the last compound, that is plaster of Paris. So plaster of Paris, the formula is calcium sulfate dot half H2O. So the chemical nature of plaster of Paris is calcium sulfate hemihydrate. Hemi means half. Okay, now this is plaster of Paris is prepared by heating gypsum at 373 Kelvin. This is important. Now what is gypsum? Gypsum formula is calcium sulfate dot 2H2O. Okay, so when we heat gypsum, we get plaster of Paris. On heating, what happens? This gypsum loses the water molecules and becomes calcium sulfate hemihydrate, which is nothing but your plaster of Paris. Okay, now plaster of Paris has a lot of uses, like it is used to fix gaps in the walls or roofs of buildings or houses. It is used in making casting for several ornaments as well as decorative materials. It is used in designing products for fire protection system. You can also write it is used in the medical, right, for joining bones and all. Also we have a lot of plaster of Paris was used before. Now the use has been reduced, but still in some places it is still used. Okay, so now let us recap all the 5 components and their formula. The first one is your sodium hydroxide, NaOH. The second one is your bleaching powder, that is CaOCl2. The next one is your baking powder, that is NaHCO3. The fourth one is washing powder, that is Na2CO3.10H2O, and the last one is plaster of Paris, that is calcium sulfate dot half H2O. 5 compounds, 5 formulas must be remembered. Okay, fine. Next is done with the theory of this chapter. We'll practice some 20 important questions that can be asked in your exams. Okay, so if you are seeing this video, then please start writing answers with me. So the first one, which of the following is a basic salt? So for basic salt, what should be there? It should be a strong base. The salt should be of a strong base and weak acid, right? So if you see here, Na, this is a weak acid, CH3COH, and NOH is a strong base. So the correct answer for this question will be option number A. Okay. Next, which of the following is a strong acid? So lemon juice, milk, these all are weak acid. HCl is a very strong acid. Okay. Next, which gas is usually, so we have come to now 2 marker questions. So here I'll tell you exactly what should be your answer framing, like how should you write the answer in the exam so that the teacher cannot reduce even a single mark for you. Okay. So now, which gas is usually liberated when an acid reacts with metal? Illustrate with an example. How will you test the presence of this gas? Okay, so when a metal reacts with acid, we get hydrogen gas. So you can write the first point here is hydrogen gas is liberated. Okay, for hydrogen gas is liberated. Okay, now you need to answer with an example. So you can write any example. Suppose Zn plus HCl, then you will get ZnCl2 plus H2. Right, so this is your example. Now second one, you need to write that how will you test the presence of this gas? So we have to, if we burn a burning matchstick, then the gas burns with a pop sound. So you can write down, when a burning matchstick is brought near, then it burns with a pop sound. It burns with a pop sound. Okay, that is how we can identify that the gas produced is nothing but hydrogen gas. Okay, now let us do the 4th question. Why does an aqueous solution of an acid conduct electricity? So you know, when aqueous solution, when you put, so first thing you need to write that when any acid, okay, for example acid is put in water, we get ions like H plus, H3O plus and Cl minus, right? So you can write down when acid is mixed with water, when acid is mixed with water, it produces ions, okay, which can conduct electricity, okay. So in this way you can answer this question, okay. You'll easily get 2 marks for this one. Okay, next, while diluting an acid, why is it recommended that the acid should be added to water and not water to the acid? Okay, so here you have to answer it in 2 parts. You should answer why acid, what happens when acid is added to water, and what happens when water is added to acid. Okay, so there should be 2 parts here. So first you write, when acid is added to water, okay, a large amount of heat is generated, okay, which is absorbed by the water. Okay, water is there, right, in the container. See, in the container you have water, right, and you added some drops of acid. So what is heat is generated, but that heat will be absorbed by the water and we do not have any problem or any accident is not caused. But if you do the reverse one, so if you write here, but if water is added to acid, the heat generated cannot be absorbed, right, and causes explosion, right. So in this way if you answer, this carries 1 mark and this carries 1 mark. Okay, so you have to write not only why it is added, but you should also explain why it should not be added in the other way. Okay, fine. Next question, under what soil condition do you think a farmer would treat the soil of his field with quicklime or slakelime or chalk or calcium carbonate? Okay, so you can see these are all bases, right. So this is a metallic oxide, this is a base, and this is a salt. So what is under what soil condition? The soil should be, if the soil is acidic, then it should be treated with these type of things to make it neutral. Okay, so just you have to mention that, you will get the full marks. Okay, next, what happens when nitric acid is added to eggshell? Okay, so if you see, you need to write nitric acid. First you need to write the reaction. Nitric acid is added to eggshell. Eggshell is made up of calcium carbonate. So we will get okay, first this is acid, right, and this is carbonates. Okay, so products here will be, you will get CO2, H2O, okay, and the salt of this one, that is calcium nitrate. Okay, so now what happens, this eggshell reacts with this one, so we can say that the eggshell dissolves in HNO3. Okay, that's all. You have to write 1 mark for reaction and 1 mark for this one. You'll get 2 marks. Okay, next, what happens when acetic acid reacts with caustic soda? So just acetic acid is CH3COH. So first you have to write a reaction plus NaOH, right? Then if you form, you will get CH3COONA plus water, right? So this reaction is 1 mark. Then you can write the second point, that a basic salt is produced. Okay, now why a basic salt is produced? Because this is a strong base and this is a weak acid, right? So the correct answer for this question we will be getting if you write these 2 points. Okay, Next, go to the next question. A milkman adds a, so this is a 3-marker question. A milkman adds a very small amount of baking soda. Okay, so if you remember, what is baking soda formula? NaHCO3, right, to fresh milk. Why does he shift the pH of the fresh milk from 6 to slightly alkaline? Okay, so here you can write down, this is done to prevent, first just write down why it is done, to prevent curding, to prevent the formation of curd. Okay, to prevent the formation of, to prevent the formation of curd. Okay, next, second one, why does this milk take a long time to set as curd? Okay, why does this milk take a long time to set as curd? Now see, this is milk. Okay, now why in milk curding happens? Formation of curd is due to the presence of lactic acid, right? So now what happens when you add this NaHCO3? Okay, now this one and this one reacts. Okay, so this one and this one reacts, so that this lactic acid is neutralized. There is no more lactic acid formed, so that is why the curd formation will be delayed. Okay, so you have to write here, the NaHSO3 added neutralizes the lactic acid present in milk, and that is why the curd formation is prevented. Okay, so just you have to write 2 points, 3 marks you will get. Okay, next question, name the acid present in and give its chemical formula. Also give the common method to get relief from discomfort caused by the ant sting. So what is the acid? That is formic acid. Okay, formic acid, first one. Next, what is the formula? That is HCOOH. Okay, so this one is 1 mark, this is 1 mark. And then how to prevent it? We have just studied in the uses of baking soda, that it is used to prevent these ant stings and all, right? So that you can write by applying baking soda, or I can say NaHCO3. Okay, fine. Next, you have two solutions A and B. The pH of solution A is 6 and the pH of solution B is B. Now which solution has more hydrogen ion concentration? Okay, so if you see that this hydrogen ion concentration is for acids, right? So if pH is 6, that is an acidic pH, so here there will be more H plus concentration. So which solution has more hydrogen ion concentration? The solution having pH 6. Next one, which of the is acidic and which one is basic? So pH is 6, that is acidic. Just you need to write, no explanation required here, just write the answer as it is asked. pH 8, that will be basic. Okay, because we know in the pH scale less than 7 is acidic, more than 7 is basic. Okay, fine. Next, okay, why do HCl, HNO3 etc. show acidic character in aqueous solution while solutions of compounds like C2H5OH and glucose do not show acidic character? Okay, so here you have to write acidic character means what? Acidic character means when a acid mixes with water, it produces H plus. Okay, when a acid is dissolved in water, it produces H plus. This is called as acidic character. Okay, now what happens? You can write down why this. First you have to explain why this shows, and then you have to explain why this does not show. So you can write down first point, when HCl or HNO3 is dissolved in water, okay, it produces H plus. Okay, second thing here you write, when C2H5OH or glucose is dissolved in water, it does not produce H plus. It does not produce H plus because they do not dissociate. Clear? because these things do not give you H plus in the water solution, so that is why they are non-conductive or they cannot show acidic character. Okay, next question. Give 3 uses for washing soda. So you can write, first is your cleaning. Washing soda cleaning, we have seen many examples, many 3 uses we have seen, we can check that. So washing soda you can cite in the glass and soap, used in the borax and removal of hardness of water, right? So cleaning, then you can write removal of hardness of water, and then in the borax formation. Okay, next one. Okay, this is important question. On hitting gypsum at 373 Kelvin, it loses water molecules and becomes a, so this is a 3-marker question again. Okay, so sorry, this is a 4-marker question. Okay, so sorry, this is a 4-mark question, case based questions. Okay, fine. This is called plaster of Paris. Plaster of Paris is a white powder, and on mixing with water it changes to gypsum, once again giving a hard solid mass. What is the molecular formula of gypsum? So gypsum, as we have discussed, calcium sulfate dot 2H2O. Okay, when we heat it, 1.5 molecules go out, calcium sulfate half H2O we get, which is plaster of Paris. Next, what are the uses of plaster of Paris? Uses you can write down for decorative items and to fill the gaps. Okay, next one. Crystals of a substance changed their color on heating in a closed test tube but regained it after some time when they were allowed to cool down. Okay, name the substance and write its formula and explain the phenomenon involved. So the substance here is copper sulfate. Okay, now when you heat copper sulfate, it loses its water molecules, and that is why it becomes white in color. Okay, so you have to write, name the substance, that is copper sulfate dot 5H2O. Okay, this is the name is copper sulfate, or name the substance, name copper sulfate does 5H2, and you can write this is also called as blue vitriol. Blue vitriol. Now what is the phenomenon when you heat it? Okay, this water, 5 water is called was water of crystallization. Water of crystallization. So when we heat it, these water of crystallization evaporate. Okay, when we heat it, this water of crystallization evaporate, and then we get the salt, which because this water of crystallization evaporate, it turns green. Okay, when you cools down, again this, it absorbs the moisture, it gains the water molecules, and again it becomes blue. Okay, fine. Next, question number 15. A compound X is bitter in taste. Okay, it is a component of washing powder, and it reacts with dilute HCl to produce brisk efflorescence due to colorless, odorless gas. So washing powder, we know it is Na2CO3. Okay, and when it will react with HCl, we know the product also, we will get NaCl, salt, plus carbon dioxide plus water, right? Okay, a compound X, so this is, we already got, this is X. To produce brisk efflorescence due to the colorless gas, so brisk efflorescence carbon dioxide, so that is Y. Okay, which terms the lime water milky due to the formation of Z. So now what will be the reaction for this one? Lime water is what? Lime water is calcium hydroxide. Okay, when you treat it with carbon dioxide, okay, we get calcium carbonate. Okay, now this is due to calcium carbonate, the lime water turns milky, right? Now, so this is my Z. Now what happens when excess of CO2 is passed, milkiness disappears due to the formation of P. Now when excess of CO2 is passed, so here we will get calcium carbonate plus water. Okay, so now I will see calcium carbonate plus water plus CO2. So if you give excess of CO2, what I will have? We will get calcium bicarbonate. Okay, now this calcium bicarbonate is soluble in water. Okay, because it is soluble, this is insoluble, or I can say this is precipitate, white precipitate, so it becomes milky in color. Now if you keep on passing the CO2, this calcium carbonate turns to calcium bicarbonate, and this becomes soluble, so that milkiness again disappears. Okay, so what I can say, when the excess of CO2 is passed, milkiness disappears due to the formation of P. Okay, identify X, Y, Z and P. So what is our X? X is sodium carbonate, right? Y is carbon dioxide. Z is which one will get? Z is calcium carbonate. Yes, due to the formation of Z, and P is your formation of P, calcium bicarbonate, CaHCO3. Okay, CaHCO3 2. Okay, fine. So here also I wrote the formula wrong, CaHCO3 whole 2. Okay, next, what will be the action of the following substance on the litmus paper? So litmus paper, if you remember, acid is there. If acid is there, then I can write blue turns to red. Okay, if acid is there, then blue turns to red, and if base is there, what happens? Base is there, then red turns to blue. This you should remember. It might be little confusing. You can remember by giving any mnemonics or something, but acid turns blue litmus to red and base turns red litmus to blue. Okay, so now if we see that dry HCl, okay, so first remember, in case of dry HCl, so in dry, so acid or base production or acid or base character is due to the production of H plus or OH minus. In dry HCl there is no production of H plus. If there is no production of H plus, there will be no change in the color. So dry HCl, there is no change. Okay, now if you see moistened ammonia, so this will give you NH4OH. Okay, so NH4OH will give you base, so it is a base, so what will turn to what? Red will turn to blue, right? Next one, C1, lemon juice. Lemon juice is again acidic in nature, right? So acidic in nature, so this will convert blue to red. Okay, next if we see D, that is carbonated soft drinks. Carbonated drinks are again acidic in nature, right? So acid in nature means it will again convert blue to red. Okay, next we have curd. Curd also contains lactic acid, that is also an acid, so it will convert blue to red. Now if you consider about soap, okay, soap is having basic alkali nature. Alkali nature means it will convert red to blue. Clear? Okay, next, what is observed when carbon dioxide gas is passed through lime water for a short duration? So if you see, for a short duration, carbon dioxide gas is passed to calcium hydroxide. For a short duration, we get the formation of calcium carbonate plus water. Okay, fine. Now if you see, so now what happens if you pass it for a longer duration? So what is there? Calcium carbonate is there, water is there, and you are passing still carbon dioxide for a longer duration. This calcium carbonate gets converted to calcium bicarbonate. Okay, calcium bicarbonate, which is soluble in water. Okay, and that is why here what happens, you can see lime water turns milky. Okay, and here this disappears, milkiness disappears. Okay, it becomes a clear solution again. Okay, so first you need to write, for a short duration it turns milky, for long duration it does not, you can write it becomes a clear solution. Then you can write the two equations for here. Okay, so 2 marks again we can get easily. Next 3 marks, complete and balance the following reaction. So first one, this is reaction of base with metal. We have seen this reaction. So base with metal will give you salt plus hydrogen gas, right? So it is Na2ZnO2, that is sodium zincate plus hydrogen gas, the first one, right? So we have NaOH plus zinc. So now if I want to balance, here it will become 2Na, here it is 2Na, 1Zn, 1Zn, 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen. Now calcium carbonate plus H2O plus CO2, so this we know it will give you calcium bicarbonate, right? So H2O plus CO2 will give you calcium bicarbonate. Okay, so now if we see 1 calcium, there is one here we have 2 carbon, here also 2 carbon, 3 oxygen, so we have 3 oxygen and 2 hydrogen. Already this reaction is balanced. Okay. Now if you see the third one, HCl plus water. So you know, in water this one HCl will give you H plus, and this H plus will react with this H2O and give you H3O plus plus Cl minus. Okay. So this is also already balanced reaction. Okay. So let us see the second last question here. Sugandha prepares HCl gas in a school laboratory using certain chemicals. She puts both dry and wet blue litmus in contact with the gas. Name the reagents used by Sugandha to prepare HCl gas. So first of all, to prepare HCl gas you need NaCl, okay, plus H2SO4. So now this one will give you Na2SO4, okay, plus HCl. Right. So I'll get 2Na, 2Na, 2Cl, 2Cl, 2H2, 2H2, SO4, SO4. Okay. So that is the reagents required is NaCl and H2SO4. Next, state the color change observed with the dry and wet blue litmus. Now you see there is an HCl produced here, right? So if there is, we know for acid, what happens? Acid blue changes to red, right? But this one will not happen with a dry. For dry, what will happen? For dry there is no change. Okay. For wet you can write blue litmus changes to red. Okay. Now show the formation of ions when HCl combines with water. So just now we wrote that when HCl combines with water we get H plus ions which combines with this one to give you H3O plus and Cl minus. Okay. Okay, last question, write the name of the product formed when zinc reacts with NaOH. So what is the name of the product? That is sodium zincate. Only name is asked, so no need to write the formula. Okay. Next, also write the balanced equation involved for the following reaction. So if you remember, sodium zincate is formed when sodium hydroxide reacts with zinc, okay, to give you sodium zincate, that is Na2ZnO2 plus water, H2. Right. So if you balance this 2Na, this is 2Na, there is one zinc, there is one zinc, 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen, so it is balanced. Now write a test to confirm the presence of the gas evolved during the, so that is your pop sound. You need to do that experiment where we have already discussed, you have to bring a burning matchstick, the gas burns with the pop sound. Okay, that you have to note down here. So with this you will be getting 3 marks for this question. Clear? Okay, so yes, now these are some questions that you need to practice. Okay, you have to solve these questions. Now a white colored powder is used by doctor for supporting the fractured bones. Write the chemical name and formula. When this powder is mixed with water, hard solid mass is obtained. Write the balanced chemical equation for the change. Next, explain the action of dilute HCl on the following with chemical equation: magnesium, sodium hydroxide, crushed egg cells. And then we have another question, state reason of the following statements: tap water conducts electricity whereas distilled water does not. Dry hydrogen chloride gas does not change the litmus color. So during summer season a milkman usually adds a very small amount of baking soda to the fresh milk. For a dilution of acid, acid is added into water and not water into acid. Ammonia is a base but does not contain hydroxyl group. Okay, so write the answers for these questions and these questions, and we will be discussing the solutions of these in the next class. Okay. Yes, so this was a one shot video on your acids, bases and salts. If you revise this and practice these questions, then I can guarantee you that you will be able to solve all the questions that is asked in your midterm examination. So the solutions of these questions I'll be discussing in my next video, and keep preparing hard. And if you have found this video helpful for your midterm preparation, do not forget to subscribe the channel. Okay. So yes, thank you for watching. See you in the next class and all the very best for your midterm examinations.